Am I audible? The screen share also not running. Is the screen visible to you now?
Yes, sir. Now it's
Okay. So you are going to start from here, question number 40. And in ascending order, I will be increasing the level of the question. So please do it. Uh, any answer, Shahid?
no, sir.
Can you repeat? Should I explain now?
Yes.
Okay. So uh, you have heard of this Van 't Hoff factor, right?
Yes, sir.
And in Van 't Hoff factor, after Van 't Hoff factor, if you have seen the formula, if you can see here, it is about the freezing point. That means delta TF is equal to, before Van 't Hoff factor, when you have studied colligative properties, you had a formula Kf into M. Yes or no?
Yes, sir.
Now, but after studying Van 't Hoff factor, the exact formula of this delta TF is equal to, delta TF is equal to I into Kf into M. Are you getting my point?
Yes, sir.
Now you need to calculate this I. And if you will study the question carefully, you have all the value of delta TF, KF, and M. As you can see, this is the value of KF. This is the value of KF. And you can also calculate the value of M, that is molality, because you can see mass of solute is given, mass of solvent is given. And you know, molality is equal to number of moles of solute and mass of solvent in kg. So with the help of this given mass of solute and given mass of solvent, you can calculate the molality. Are you getting my point?
Yes, sir.
And also you can see the freezing point is changed by, basically, this is the value of delta TF that is given. Just wait a minute. It will just. So as you have seen, are you able to see the stream?
Yes, sir.
Okay, so you can see this is your KF. With the help of given mass of solute and given mass of solvent, you can calculate M, and you can see delta TF is also given. So directly you can apply the formula here and you will get it. 3.28 it will be basically. You can see the freezing point is changed by minus 3.82 degrees centigrade. So delta TF You can use the freezing point of water, freezing point of pure water minus freezing point of solution. So the freezing point of pure water is 0 degree centigrade, and this is what given uh, 3.82, and accordingly you can write the value minus 3.82, and you will be getting delta TF is equal to 3.82 degrees centigrade. Directly you can put here. So please do write it. Actually, do solve this. Get me the answer. Are you done with this, Shahid?
Yes, sir.
Okay. Faiza, are you there? Please do solve this. 41. Now, Faiza, I'm gonna show you the previous question. You can take a screenshot of this question number 40. It's quite good. Please take a screenshot and do practice at home. If you will get any problem, ask me. Are you done with the screenshot? Very good. Now go for this question number. Just wait a minute. Oh, very good, Shahid. Very good, Faiza. Both of you are correct for this question number 52. Please go for this. This question is quite easy. They just played with the formula. They modified the formula only. No, it's wrong. Please do check it, cross check it. Shahid. Please do cross check it. Hmm. Faiza, it's wrong. Should I explain? Shahid and Faiza. Yes, Faiza, now you are right. Okay. So you are aware of this PV is equal to an RT, both of you, right? Yes or no? Shahid,
Yes, sir.
this P, I'm gonna this tracer, I'm gonna uh, denote this with pi. Pi, that is osmotic pressure. Pi V is equal to nRT, and N is given mass upon molar mass R into T. And as you can see in the question, it has been asked which of the following can be used to calculate molecular mass of solute in terms of osmotic pressure. So you can see this is the solute, number of moles of solute, and this is the molecular mass of solute. So M will be equal to, you can see M upon V, we can write RT, and this pi will also come in denominator. So according to this, the formula is your B. Are you getting my point? Shahid and Faiza. Shahid is not V, pi is there. Repeated it. Pi. Or you can directly use the formula. Pi is equal to MRT if you have studied. This is the formula of osmotic pressure. And here M is molarity. You know that. Now, M can be written as number of moles of solute upon volume of solution in liter, and R and T, and this pi will be as it is. Now pi will be written as this, and number of moles of solute given mass upon molar mass upon V into R into T. Now I can also write M upon M into V into R into T. But we need to calculate the value of molar mass. So M will be equal to M upon V into RT upon pi. And in the form, in the option, it is given that M is denoted by M. So M2 can be written as of. So in this way, with the help of directly the formula of osmotic pressure, you can get this answer. Let me know when you are done with this. Let me know when you are done with this, both of you. You can go for question number this. Oh, very good, Faiza. Any answer from you, Shahid? Yeah, it's very easy. Question number next 54. That's good, Faiza. How did you solve it? So we had this question in school test, but that's great. But what is the concept behind this correct answer of yours? How did you solve it? Or you just remember the question? That's great. Your memory power is quite good. But I want to know the explanation behind this question. Okay, remember what's the... Okay, no problem. Any answer from you, Shahid? Basically, as you know that uh, delta TF, that is depression in freezing point, directly. This depression in freezing point is colligative property, and colligative property depends upon the number of solute particles. So depression in freezing point, I can write. Please understand the concept behind this. Depression in freezing point directly proportional to number of particles. Number of particles. And this number of particles can be calculated with the help of I. I is your Van 't Hoff factor. And how you are going to calculate the value of I here? So first you are going to dissociate it if it can be dissociated, and you know that this will be dissociated into Al plus 3 plus SO4 minus 2. And after balancing it, you will get 5 particles for this. And if you are going to dissociate this KCl, you will get 2 particles. And if you are going to dissociate this C6H12O6 and C12H22O11, if you are going to dissociate this both, this is basically your non-electrolyte, or you can say non-volatile, so it will not be dissociated. The value for I for this is 1. So you can see for this both I is equal to 1, and for this 2 and 5. And you can see depression in freezing point is directly proportional to number of particles. So in which the number of particles will be greater, the one which has greater number of particles is the one having the lowest freezing point, because there will be most depression in freezing points. So that's why the answer will be A. Faisa, have you got it? Very good, Shahid. Maximum number of particles and maximum depression in freezing point, lowest freezing point it will be. So number of particles increases, depression in freezing point, that means the freezing point will decrease, that means indirectly lowest freezing point. You can relate this like this. Let me know when you are done with this. So we have class till 10:30 IST. Time. We have a class for 1.5 hours. Okay. Let me know when you are done. Shahid, are you done with this?
Yes, sir.
Hmm. So you are also done with this, right? Are you done with this, both of you? So someone answered this. Very good. Faiza, very good. Any answer from you, Shahid? No, not option C. It's wrong. I'm going to explain. You can see at 25 degrees centigrade, temperature is constant. The highest osmotic pressure. You can see osmotic pressure is equal to M into R into T. In the question, you can see temperature T is constant for all the option that is given. Okay. And R is universal gas constant. You know that all depends upon M, but M is also constant. So you are going to take in consideration of this I. I is your Van 't Hoff factor. This is the final formula of colligative property, IMRT. Generally, before colligative properties, whatever question you have studied or solved, the question is by default I equals to 1, so it doesn't affect. But after studying colligative properties, you have to take care of this I. Very important it is. Always check this I. How you are going to calculate I? If the compounds or whatever is given, solute or solvent, if it is non-volatile, I will be one. And basically non-electrolyte, you can see the one which cannot be converted into ions, like glucose and urea. So this glucose and urea, I has one, I has one. Here, if you are going to calculate, you will get 2, I is equal to 2, and here the value will be 3. Are you getting my point, Shahid? How I am writing this I is equal to 3, I is equal to 2?
Yes, sir.
Shahid? Yeah. So you can see the value, the pi depends upon the value of I, Van't Hoff factor. So the answer here will be A, because it has the maximum value of I. MRT, these are constant. So can I change the slide? Okay, thank you. Moving to the last question of this easy path. This is very easy question. The which one is colligative? Which one is a colligative property? Which one is a colligative? Now the question should be which one is not a colligative property? Not a colligative property. Just wait a minute. The question is right. The question is right. Which one is colligative property? Can you repeat your answer, Faiza? The question is right. Yeah, boiling point is not. Elevation in boiling point is colligative property. Alone, separately, boiling point is not a colligative property. Vapor pressure is also not a colligative property, but relative lowering in vapor pressure is colligative property. Freezing point is not a colligative property, but depression in freezing point is a colligative property. Osmotic pressure is colligative property. Very good. Now we are going to solve some questions based some questions from JEE Mains. Just wait a minute, please. So I'm going to give you a question. Take your time, but so not that much talk with you for this. Visible clearly to both of you. Clearly. Shahid and Faiza, am I audible both of you? Faiza, am I audible to you? Okay, Shahid, just let me know whenever I will be lagging. I don't know why it's okay. Shahid, let me know whenever uh, I'm lagging. My voice is lagging. Will you be able to solve this? Shahid, wrong answer. Faiza, right answer. Yeah, Shahid. Yeah, it's good. Very good. So you can say first you need to calculate the value of I for this, and you know how to calculate. If you are going to dissociate it, you will be getting 4k plus FeCN whole 6 raised to the power minus 4. Total number of ions 5. So the value of ion will be I will be 5 upon 1, that is equal to 5. And now you need to calculate. If you are going to see this has a value I is equal to 5. So the answer is A. If can you tell me the value of I for this AlNO3 whole thrice? Can you tell me the value of this AlNO3 whole thrice? That's great. What about this D? Faiza, I want answer from you as well. What is the value of I is equal to 6 for D? Shahid? No, it's wrong. Please do dissociate it again. Yes, it's right, Faiza. Why you have doubt in your answer, Faiza? I always see whenever you are telling me the answer, there will be a question mark. Is it right, sir? You should have confidence whenever you are giving answer. Otherwise, it will be very harmful. Like in competitive exams, you will get negative marks unless or until uh, you are having your confidence on any answer. Are you getting my point, Faiza? So please be confident. Any answer, Shahid, for this Na2SO4 for D? For D, I is equal to 3. That's good. No, I'm going to explain. So, Sahid, this is your Na2SO4. If you are going to dissociate this, you can see there will be Na plus here it is SO4 minus. Now, if you want to balance it, you are going to multiply it by 2. Now, I is equal to number of particles after dissociation or association. You can see here it is dissociation. So, number of particles 2 plus 1, that is 3. Upon before dissociation, 1. So, the value of I for D, option D, is 3. Why you are telling me 6 it is, Shahid? Never add like this, 2 for this and 4 for that. Always do this. Okay. Can I change the slide? Okay, thank you. Now, for one more question, we will move to the level of JEE Mains. So this is question number 59. Which of the following echo solution has minimum freezing point? We already have done this type of question. Please do it. Oh, no, it will not be answer C. Just wait a minute. Minimum freezing point. If you are going to say it carefully, you can see molality is also given. So delta TF, as you know that delta TF is equal to I into KF into M. It is depending upon this and this. This will be constant. Are you getting my point, both of you? So if you are going to see, this will have I is equal to 3. This will have I is equal to 2. This will have I is equal to 1. And this will have I is equal to 2. But at the same time, you can see the value of this 0.01 M. And this is your 0.05 M. If you are going to multiply, you will be getting 3 5s of 15. That means 0.015. But if you are going to multiply it by 2, you can see that means to 0.01. In KF is also there. It will be 0.0. Getting my point, which is greater. I think this one is greater. Shahid, Faiza, should I explain in more? Oh, sir, your voice was lagging. Okay, okay. It is like, just wait a minute. Faiza, am I audible? Oh, there is power cut off. Not a problem. Okay. So Faiza, what I was saying is that you can see this is the formula. Delta TF is equal to I into K into M, KF into M. And you know that I into M and KF is constant for all the options. I and M is varying. For the first one, it is 2I and M is 0.01 and KF is as it is. For the second one, I is equal to 1. For the third one, I is equal to 2. So if and for the third, for the C, third one I is equal to 3. So for MgI2, I'm gonna calculate. So here delta TF will be equal to I is 3 and M is 0.05 and KF is as it is. So if you are going to multiply it 0.005, if you are going to multiply it, you will be getting 0.01 3 5s are 15, 0.015 into KF. And for NaCl, if you are going to multiply it, you will be getting 0.02 into KF. Which one is greater, NaCl or MgI2? So you can write A. A is the answer. Okay. Can we move to the next question? Okay. Now I'm going to give you questions from JEE Mains, and this is the first question from JEE Mains I'm giving. And we also have done this type of question. You need to calculate the molality of the solution. 2021. Any answer? Let me know if you're not able to solve this. Yes, I can explain this. The density. Shahid, any answer? It's very easy. Okay, no problem. See, I'm going to explain it. It's very, very easy. You can see, first of all, density of any solution is this much. The molality of this solution is round off to the nearest integer. Atomic mass of all the atoms are given and density of water is also given. We need to calculate the molality of this solution. So you know that for molality, what is the formula? Number of moles of solute upon mass of solvent in kg. This is the formula. Yes or no? There is nothing given about solvent. So we are going to consider the solvent. Consider, let 1 liter of the solution. You can take 1 liter solution. There is nothing given about the volume of the solution. So I considered that the volume of the solution is 1 liter. 1 liter, or you can take it as 1000 gram. As you know that density of water is equal to 1 gram per ml. Density of water is 1 gram per ml as given. So mass of solution is equal to density into volume. Density of solution into volume of solution. So how did we get density of solution? That is given in the question. Density of solution, that is 1.2 gram per centimeter cube into volume of solution, that is 1 liter, that means 1000 we can take, and this can be written as 1200 gram. Are you getting my point, both of you? This is the mass of solution. This is the mass of solution. But we need mass of solvent in kg and number of moles of solute. So what we need to do, let mass of NaOH, just neglect it, not let. Basically, we need to neglect the mass of NaOH because the quantity of water is quite large. So neglecting mass of NaOH, mass of water will be, that means mass of solvent, mass of water, or what we can write, mass of water or mass of solvent will be equal to 1000 gram. And here you can see mass of solution we have calculated 1200 gram. So mass of just wait a minute, we need to calculate mass of NaOH. We cannot neglect mass of NaOH because we need to calculate the number of moles. We need to basically neglecting volume of NaOH, sorry, neglecting volume of NaOH. We need to neglect volume of NaOH because the quantity of NaOH is quite less. So mass of water will be 1000 gram. So mass of NaOH, that means solute, will be equal to, what is the mass of solution? 1200. And what is the mass of solvent? That is 1000. So this will be equal to 200 gram. Just wait a minute, it will be, sorry. Okay, now you are able to see this. 1200 minus 1000. So mass of NaOH, that is solute, that is 200 gram. Now you can easily put the value here. You can see number of moles of solute, that is given mass, that is 200 gram upon molar mass. If you are going to calculate the molar mass of NaOH, that is 40 upon mass of solvent in kg. 1000 gram is the mass of water. So it will be 1000 divided by 1000, that means 1. So if you are going to solve this, you will be getting 5m, that is the molality. So the answer here will be 5. Here will be 5. I will again explain. First, you are going to write it in your own way and let me know. It's very easy. You just needed to let the mass of solution only, and accordingly you can solve this. So please do write it first. Let me know when you are done with this. I will again explain this. Shahid, are you done with this?
Yes, sir.
So you can see in the question, only the density of solution is given, nothing else. And water, the density of water is always, you need to uh, remember this. It is also given. You needed to calculate the molality of solution. Nothing else is given in the question. So you have to consider the solution volume. Let it be 1 liter solution. I that volume of solution is 1 liter. That means 100 ml has a mass 1000 gram. And you can see, am I audible clearly? You can see density of water is this much and mass of solution. You can easily calculate since you have considered this volume as 1 liter, 1000 gram. So in this way, mass of solution is 1200 gram. Now what you need to do, the volume of solution, the volume of NaOH, that means solute, we are going to neglect it so that we will be able to consider this 1000 gram solution, volume of solution as mass of water or solvent. And in this way, you get the mass of solvent to put it here. And if you have got the mass of solvent, you can easily calculate mass of solute by subtracting mass of solution minus mass of solvent, and you will get this. After getting the mass of solute, you can easily calculate this and you will get your answer. Very easy. Now I'm gonna give you another question. This one is also quite easy. Please do this. No, Shahid, the class is for 1.5 hours. Are you have you informed for this 1 hour or 1.5 hours? Are you able to solve this? Very good. Just let me know if you have got anything. Faiza, any answer? Very good, Shahid. You have got the right answer. What about you, Faiza? It's not A, it's B basically. Can you cross check your answer? Because there is minor difference in between these two. Power cutter. Will you be able to answer this? This question I'm gonna give you is the last on concentration term. Faiza, did you check your calculation for question number 11? Have you got the right answer? The right answer is B, or should I explain it? Please do let me know. Shahid, you can go for question number 15. Very good, Faiza. Both of you can go for question number 15. 8 gram of NaOH is dissolved in 18 gram of H2O, mole fraction of NaOH in solution, and molality of the solution respectively. You need to calculate. Very easy it is. Very good, Shahid. You have got the correct answer. What about you, Faiza? Any answer for question number 15? Faiza, any answer for question number 15? Or not B. You have calculated only one this. Have you calculated the molality correctly? Yes or no? Or you have just calculated one part? I'm gonna show you. This part is correct that you have told us. That is this. You need to calculate molality. Molality is number of moles of solute upon mass of solvent in kg. What is the number of moles of solute? Given mass upon molar mass. Mass of solvent, that is 18 divided by 1000. So if you are going to solve it, it will be 8 by 40 into 1000 upon 18. This 0 and 0 will be cancelled. This will be cancelled by 2 times and this will be cancelled by 9 times. Now you can see 100 by 9. So it will be 11.11. So the correct answer is D, not B. Is that clear, Faiza? Very good. Now moving to the question, next question, that is your 27. Take your time, but do it correctly. Let me know if you're facing any kind of problem in this question. Are you done with this? Both of you? Yes or no? Faiza, Shahid. No, sir. Okay. See, I'm going to explain this. This is also very easy. Vapor pressure of A and B at 25 degrees centigrade is 90 mmHg and 15 mmHg respectively. If A and B are mixed such that the mole fraction of A, you can see vapor pressure of A P naught A is given as 90 and P naught B is given as 15. It is also given that mole fraction of A is 0.6. You can easily calculate the mole fraction of B by 1 minus 0.6, that will be 0.4. You need to calculate the mole fraction of B in vapor phase. You need to calculate the mole fraction of B in vapor phase. So I'm going to explain this. You can see PT will be equal to partial pressure of A plus partial pressure of B. Partial pressure of A will be equal to P naught A zeta A plus P naught B zeta B. With the help of this formula, Rolle's law, you can easily apply this formula 0.90 into 0.6 plus here it is 15 into 0.4, and here you can see it will be 54 and here it will be 6. So total vapor pressure of the solution, that will be equal to your 60 mmHg. Now you need to calculate the mole fraction of B in vapor phase. You know what? Here we are going to use Dalton's law of partial pressure. Dalton's law of partial pressure. What does it say? It says that partial pressure of any gas is equal to mole fraction of that gas, basically in vapor phase, into total pressure. So since I have represented this mole fraction of gas with Y, so I'm going to denote it by YB is equal to partial pressure of B upon total pressure of T. You can see partial pressure of B is basically equal to P naught zeta B upon total pressure PT. P naught, am I audible clearly? Am I audible clearly? So here
Yes, sir.
you can write 15 into 0.4 upon 60. And if you are going to calculate it, you will be getting 15 4. Just wait a minute. Just want to solve it. This will be equal to 6 upon 60, that is 0.1. And you can see here into 10 raised to the power. Here total value is 1 into 10 raised to the power minus 1, and we need to calculate 10 raised to the power minus 1 is already given. So here the value of x is equal to 1. So the value of x is 1. So it is quite good question. Don't be confused while solving mole fraction in Rolle's law. In Rolle's law, we take the mole fraction of liquids, and whenever it talks about the mole fraction of vapor, we are going to use the Dalton's law of partial pressure. Is that clear, both of you?
Yes, sir.
Okay. Please do write it and let me know. Let me know when you are done with this so that we will move to the next question. And this type of question will be asked in your JEE mails. Both of you done with this. Okay, so this is the last question. I'll see you in the next class and let me know which chapter we are going to start. Which chapter you have covered in coaching? Electrochemistry? Yes or no?
Yes.
So in electrochemistry, up to basically galvanic cell, conductance, that is your molar conductivity, equivalent conductivity, and also nurse diffusion. These three topics you are going to revise on coming Monday, and we are going to do questions. Okay. So this is it for